How's it going, everybody? So we're going to be talking about the quadratic formula today. What you can see before you is the formula itself and is showing you basically where all the values are going to be plugged into the formula. And the idea behind the quadratic formula is it can be used in substitute of factoring, in substitute of the square root method, or completing the square. You can use the quadratic formula on any quadratic equation and it will help you find the x-intercepts. Now, taking a look and utilizing this formula in depth, let's go ahead and start a problem. So we have ourselves a x squared plus 3x minus 5 is equal to 0. Now the idea is that we're going to identify the a, the b, and the c, and then we're going to plug that into our equation. So we have ourselves a 1, 3, and negative 5. And so when plugging this into the quadratic formula, you have yourself an x is equal to a negative b, which is 3, plus or minus the square root of b squared. So we have 3 squared minus the constant 4 times 1, and then c, negative 5. So what this is going to give me is a positive value in the square root, so I should end up with 2 real solutions. And then, of course, divided by 2a, which is 2 times 1. So when we go to simplify this by hand, we have ourselves a negative times the 3, so that's a negative 3, plus or minus the square root of 9 minus 4 times 1 times negative 5. That ends up being a positive 20, divided by 2 times 1, which is 2. So now looking at this right here, we're going to go ahead and simplify, and we have 9 plus 20, and that's going to be negative 3 plus or minus the square root of 29. Now, the square root of 29 does not come out to a nice pretty whole number, and also 29 is a prime number. There's no multiples of 29 beyond 1 times himself. So we actually are going to leave our answer just like this. Now please understand this represents 2 different solutions though. This represents x is equal to negative 3 plus square root of 29 divided by 2. And also equals negative 3 minus the square root of 29 divided by 2. So just be aware that there are 2 unique solutions, not just one, okay? And so that's basically what we're doing today. Let's take a look at another one. If I have a x squared plus 8x plus 41 equals 0, let's find my a, let's find my b, and my c. A is 1, b is 8, and c is 41. And so when we go ahead and put all this together, we have x is equal to my negative b, so my negative 8, plus or minus the square root of b squared, which is 8 squared, minus 4ac, which is 1 times positive 41. Now, this will go ahead and be divided by 2 times 1. And now we go ahead and we're going to simplify. So this is going to give me x is equal to negative 8 plus or minus the square root of 64 minus 164, because 4 times 1 times 41 is 164. And this is all divided by 2. Now, what we can do is go ahead and subtract all that, and that's negative 8 plus or minus the square root of negative 100. Now, we know how to deal with negatives. We take the negative out as I, and so we're left with x is equal to negative 8 plus or minus I, square root of 100, divided by 2. Now, we do have the ability to go ahead and take the square root of 100, and that does come out to a nice even number. That's going to come out as 10. So you have plus or minus 10i. Now, this is all divided by 2, and we could simplify that because 8 is divisible by 2 and 10 is divisible by 2. And a lot of the time, most people like you to go ahead and simplify that when appropriate. So negative 8 divided by 2 is negative 4. 10 divided by 2 is going to be 5. And so this right here represents your solution. And so you have x is equal to -4 plus 5i. And then you have x is equal to -4 minus 5i. And so you'll go ahead and keep working on the rest of these problems utilizing the quadratic formula. Let me know if you need absolutely anything, and great job today, guys.